Hey good people, I decided to make this video since we're actually starting something new. We're going to learn about piecewise functions today, and I'm going to attach a few things. I'm going to attach a copy of an extra practice worksheet with the answers at the end. I'm going to also attach this section from the textbook along with some problems that you could try. And I'm going to close my video now and get started. So a piecewise function is a function that is defined differently for different input values. Here is an example. This is a piecewise function that I just made in the program called GeoGebra. This is a free program that you could download and install, or you could actually just use it within your browser. It's GeoGebra. So this function looks like a few different graphs put together, and that's sort of what piecewise functions are. So if you notice here, this function is defined as f of x is equal to 0 when x is in between 0 and 3. So when x is greater than or equal to 0 and less than or equal to 3, this function is defined as just equal to 0. Then, for x values greater than 3, greater than or equal to 3, and less than 10, x is actually equal to this linear equation here. And if x is greater than or equal to 10 and less than 13, x is defined as positive 3. And finally, if x is greater than or equal to 13 and less than 16, this last domain restriction, it's defined as this complicated function right here, which is actually part of a circle. And these piecewise functions are used a lot in computer programming, specifically in like video game design, to make textures. If you notice, the piecewise function I made here sort of looks like a ramp that you might find in like a Tony Hawk's Pro Skater video game. Here is a more dry mathematical example, right? Consider this piecewise function here. F of x is defined as 1 minus x if x is less than 1. And if x is greater than or equal to 1, it's defined as the square root of x minus 1. Evaluate the function as indicated. So we're asked to evaluate this function for different values of x. And when I take this f of negative 2, I have to first determine this input value, which part of this domain it applies to. So is negative 2 greater than or equal to 1? No, it's actually less than 1. So we're going to actually plug that into this function here. So f of negative 2 is equal to 1 minus x. And in this case, x is negative 2. So it equals 3. This next value here, f of 1, is the number 1, is that less than 1? No, it's greater than or equal to 1. So we actually want to plug it into this part of the function. So the square root of x minus 1, the quantity x minus 1, and we're plugging in 1 for x, and we get 0. So f of 1 is equal to 0. And we're going to evaluate the function next for f equal to 3, or for f of 3, for x equal to 3. And we're going to plug 3 into which part of the function? Is 3 less than 1 or greater than or equal to 1? It's greater than or equal to 1, so we plug it into this part of the function. So now I'm going to plug in 3 here. And we get x is equal to the square root of 2, or 1.414. Alright, let's plug in our last number here, 10. Since 10 is greater than or equal to 1, we're going to plug it into this part of the function. And I'm just going to replace my input with a 10 here. and f of 10 is equal to 3. Alright, so we just evaluated our first piecewise function. Let's do another one. If you want, you can pause the video now and try this problem on your own. I'm going to go ahead and do this problem, and you can check your work. F of negative 2. F of negative 2, since negative 2 is less than or equal to 1, we're going to plug it into the top part of this function here. Let's see. F of negative 2. We have x squared plus 3x and we get negative 2 as our output. Let's do another one. F of 0. Since 0 is less than or equal to 1, again, we're going to plug it into the top part of this function here. 0 squared plus 3 times 0. And we get 0 as our output. Let's plug in 1 into this function. Is 1 greater than 1 or less than or equal to 1? Well, since 1 is equal to 1, we're going to, again, plug it into the top part of this function here. And I'm just going to go ahead and replace my calculator entry with a 1 as my input. And we get 4 as our output. Finally, let's evaluate the function for x equal to 5. Is 5 less than or equal to 1? No, it's actually greater than 1, so we're going to plug it into this part of the function for the first time. So we have 2x cubed minus 2x. And when evaluating the function for x equal to 5, we get 240. F of 5 is 240. So we just evaluated this piecewise function for these 4 different specified input values. When you're graphing piecewise functions, you could graph each part of the piecewise function separately, paying attention to the domain restrictions, or you could just draw the graph by graphing each part entirely and then erasing the parts that don't belong there at the end based on the conditional domain restrictions. So I like to do it the second way. I like to draw the whole graph out and then kind of just erase what doesn't belong there because I think it's easier for me. So I'm going to graph the first thing here in blue. F of x is equal to 1 minus x. Another way to think about that is f of x is equal to negative x plus 1. That's sort of in mx plus b form. So we have a y-intercept at positive 1, and our slope is negative 1, down 1 over 1. I'm going to go ahead and connect those the straight line. And let's think about what belongs there and what doesn't belong there. This is only supposed to be the graph for the x values that are less than 1. So for all x strictly less than 1, I should have this picture. So I want to basically erase everything to the left of that point. And I'm going to do that now. I'm going to also, since it says strictly less than 1, 1 is not actually included in that domain, so I'm going to make that an open circle. So this is the graph for all x values less than 1. And that looks better. Okay, let's do the other part. F of x is equal to the square root of x minus 1. If you remember the parent function, the square root function, this could be helpful. The parent function of the square root function starts here and it goes up like this. Now, since this one has a minus 1, if you remember what we learned about our transformations, you can actually just shift this over 1 unit actually to the right. So this is going to be shifted over 1 unit to the right, and it's going to be the square root function. The square root of 1 minus 1 is the square root of 0 is 0. Now let's put we put in 2. 2 minus 1 is equal to 1, and the square root of 1 is 1. If we put in 5, for instance, 5 minus 1 is 4, and the square root of 4 is 2. So if I go over to 1, 2, 3, 4, 5, my output is 2. And that's enough points for me to make this graph. So, I'm going to make a final graph now based off that picture. Let me do this in a different color. So we have the square root, and this goes infinitely in each direction. So that's what my graph looks like. Alright, let's do another example. Alright, another example. If you want, you can pause the video now and try this one on your own. I'm going to go ahead and do the problem now. So the first part of our graph, x squared minus 1, is a parabola that is shifted down 1 unit. So we're just going to graph a regular right side up parabola like this. But since it says minus 1, we're going to shift that down 1 unit. Oops, that's not. I think that's about all that can fit on here. Yeah. Alright, and the next part of our graph is f of x is equal to x minus 1. And that is a standard linear equation with a slope of 1, a y-intercept of negative 1. I'm going to go up 1 over 1 and make a nice line here. Alright, now let's consider the domain restrictions. For the x values less than or equal to 2, we're going to go by the blue graph. And for the x values greater than 2, we're going to go by the red graph. So I actually want to delete or erase this spot of the blue graph all the way anything after 2. And then for our red graph, it's defined as soon as it's greater than 2. So I'm actually going to use an open circle since it says x is strictly greater than 2. I'm going to use an open circle beginning at 2. Let me try to make that a little cleaner. Up 1 over 1. Alright, I'm going to put some arrows on my graph to indicate that it continues. And that's it. So our graph is defined as this parabola for all x values less than or equal to 2. And it's defined as this straight line here for all x values strictly greater than 2. Alright, there are some problems that you could use to practice this new topic in the chapter that I attached. You can go to page 114 and do these 4 problems, 45, 46, 47, and 48. I highlighted them for you on the PDF that I attached. The problems have instructions, but what I'd like you to do is evaluate them for these input values. And you could plot those points if you'd like. Then sketch a rough graph of each function without using a calculator. If you'd like to use a calculator to check your work, you could try to type this into GeoGebra, and that could be a helpful way to check your work with these piecewise functions. Alrighty, thank you for watching. If you have any questions, please reach out via email or Google Classroom. Again, I miss all you guys so much. I look forward to seeing you again. I don't know when that's going to be, but please keep in touch. Email me questions, comments. Thank you.